Hey guys, I hope you're having a great week so far. We're going to continue on in our book on lesson 5, talking about negative exponents. And again, we're focusing on why is it helpful to write numbers in a different way? Why is it helpful to be able to identify rational and irrational numbers? Number 1 wants us to write a ratio. If you read over this is a table of wing beats per minute of a small butterfly versus a housefly. As you can see, the housefly beats its wings a lot quicker than a butterfly does. And it says write a ratio. Well, anytime you see the word ratio, that means that you're going to write a fraction. And it says the butterfly to the housefly. So that automatically tells me what goes on top and what goes on bottom. So the butterfly was mentioned first, so it's my top number, and the butterfly was 100. The housefly then becomes my denominator, and it was 10,000. And hopefully you know that these can be reduced. These 2 zeros can take off 2 zeros down here, and I'm left with 1 over 100. Now let's say that I want to put an exponent as my denominator. I don't want this to be 100. So I have to think, well, what times what gives me 100? Well, the answer is 10 times 10. So I could rewrite this as 1 over 10 times 10. And if I wanted to use a power, how many 10s do I have? Well, I have 10 of them. So it's 1 over 10 to the second power, or 0.01. Okay? So now let's apply that. Let's look at this table. And it says complete the first 4 rows of the table showing the exponential and standard forms of power of 10. So we're only dealing with powers of 10 right here. But we want to go ahead and complete it. And this goes back to what we did 2 chapters ago when we were talking about powers. 10 to the third power, that means I'm taking 10 times 10 times 10. I have 3 of them, and I'm multiplying them together. 10 times 10 times 10 is 1,000. How many 10s do I have to multiply to get 100? Well, I know that if I take 10 times 10, it will equal 100. So how many 10s do I have? And the answer is 2 of them. So that's 10 to the second power. 10 to the first power is just a 10 by itself. It's a single 10. So 10 to the first power is 10. 10 to the 0 power, hopefully you remember that any number to the 0 power is 1. So if I look from here to here in relationship to my zeros, here I have 3, here I have 2, so I took away a 0. Then I went from 2 zeros to 1 0, so I took away a 0. I went from 1 0 to no zeros, so I took away a 0. Okay? So now, what if I had a 10 to the negative 1 power? All that means is that you're going to now turn this into a fraction or a ratio. And it's going to be 1 over 10 to that power. So to get rid of the negative exponent, it becomes 1 over 10 to the first power. And 10 to the first power is 10. Okay, so let's do 10 to the negative 2 power. To get rid of the negative, I make it 10 to the 1 over 10 to the second power, which is the same as 1 over 10 times 10, which is the same as 1 over 100. 10 to the negative third power. Again, turn it into a fraction, where the 10 to the third power becomes the bottom number, the denominator, to get rid of the negative. And I end up with 1 over 10 times 10 times 10, which equals 1 over 1,000. Okay? Now let's answer these. What operation was performed when I moved in the table? Well, obviously from here to here, I started doing division. And what happens to the exponent? Well, I went from 3 to 1, 0, negative 1, negative 2, negative 3. Hopefully you know that it decreases by 1. Each time. Okay? Let's go on to page number 44. And this is talking about zero exponents. We just talked about that for a second. But a zero exponent, anytime you have any number raised to the 0 power, the answer is 1. So I could have 4,729. As long as it's to the 0 power, and no, this isn't a degree sign. I know that you're used to seeing that, but this is a power of 0. Regardless of how big that number is, it equals 1. Okay? Anytime I have a negative exponent, all I have to do is turn that into a fraction and put that entire term on the denominator side of the fraction, the bottom of the fraction, and that exponent becomes positive. So let's look at a couple of these. Well, on this one I have 6 to the negative 3. Just like I said, you have to turn it into a fraction where the 6 to the negative 3 moves to the bottom of it, making it positive. So you end up with 1 over 6 to the negative, or I'm sorry, 1 over 6 cubed. Let's look at A, 7 to the negative 2. Again, I'm just going to turn that into a fraction where 7 to the negative 2 is going to be my denominator, therefore making that negative positive. So I end up with 1 over 7 squared, and 7 times 7 is 49. Okay, let's jump down to D. It says m to the negative third. Again, I'm going to turn that into a fraction where I'm going to move this entire term to the bottom of the fraction to get rid of that negative 3. So it becomes 1 over m to the positive third. Okay? Now this next section, it says write each fraction as an expression using a negative exponent. So if I look at this one, I know that it's 5 to the positive 2 now, but remember, on these, I made it into a fraction, and all I'm doing now is undoing the fraction. So I know that this then becomes 5 to the negative 2. This one is 1/36. 6 times 6 gives me 36, so that's 6 squared. So this becomes 6 to the negative 2. Let's look at E. I have 1 over 8 cubed. If I wrote this expression with a negative fraction, that exponent just becomes negative. So I have 8 to the negative third. 27. Well, if I think about 27, what numbers multiply to give me 27? I can do 2 times, no, I'm not, sorry, not 2, 3 times 9, and 9 is a factor of 3, so I can do 1 over 3 times 3 times 3. So how many 3's did I have? I had 1, 2, 3 3's. So that's the same as 3 to the third. So now I can take this and write it with a negative exponent of 3 to the negative third. Okay? Finally, let's look at this one. And it's talking about a water molecule. We're going to go ahead and go on to this one because I think you can follow this pretty well, but we're going to go ahead and go to the water molecule. Wow, that's a lot of numbers. Okay? Again, I can count zeros. So I'm going to start with a power of 10. So I know that it's going to be 10 to something. So now if I count zeros, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And because it's a decimal, I know it's going to be negative, so it's going to be 10 to the negative 10 power. Okay? Our final examples are doing the same thing, only now we're doing multiplication and division. So if I have like bases, I have a like base of 5, I still subtract the exponents. So I have a 3, I'm sorry, I add the exponents because I'm multiplying. So I have a common base of 5 and I add 3 plus a negative 5, and hopefully you know that a 3 plus negative 5 is a negative 2. So then I end up with 5 to the negative 2. If I want to turn that into a fraction so that I don't have the negative 2, I simply put 1 over 5 squared, which becomes 1/25. Let's look at 7. On number 7, because it's division, I subtract my exponents. So I have a negative 1 minus a negative 4. 2 minuses together make a plus. So it's negative 1 plus 4. And a negative 1 plus 4 is 3. So I end up with a W cubed. Let's do letter J. I have 3 to the negative 8th times 3 to the squared. So I'm going to have a common base of 3. Because I'm multiplying, I add the exponents. A negative 8 and a positive 2 give me a 3 to the negative 6th. I don't want to leave it in that form. I want to get rid of the negative on the exponent, so I have to turn it into a fraction of 1 over 3/6. If you want to go ahead and multiply that out, you can. If you want to leave it 1 over 3/6, we're okay with that too. So I end up with 1 over 729. Either form we will accept. Let's look on an M. M is a division problem, so I'm going to subtract exponents, so I have a like base of B. I have a negative 4 minus a negative 7. 2 negatives together make a positive, so I have a negative 4 plus 7. Negative 4 plus 7 is a B to the 3rd, and that's my final answer. All right, guys, go ahead and go through and try to do some problems. If you have any questions, bring them up to us tomorrow. Make sure that you jot them down and write them in the columns of your book so that you won't forget what they are. And have a great night. We'll see you tomorrow.